So now we're about to start talking about absolute value. So I want you to notice here that 0 is in the middle of this graph. So what are some similarities and what are some differences between those 2 points that are marked in red, obviously? So, I think the difference is pretty obvious. One is positive 7 and one is negative 7. However, with respect to 0, which is kind of like the origin or the beginning of the graph, they're the same exact distance away from 0. And there are times and places where that's important. Like, for instance, I don't know, let me guess that some town in Kansas is in the middle of America and call it Wichita, just because Wichita is the only town in Kansas I know off the top of my head. So let's say that New York and Los Angeles are the same exact distance from Wichita, Kansas. Okay? So if I said, how far is Los Angeles from Wichita? You would say, it's whatever, 1,500 miles. If I said, how far is New York from Wichita? You'd say 1,500 miles. So they share this trait in common about being the same distance from 0. That distance from 0, we call the absolute value. In other words, I'm not going to care about direction, which positives and negatives do, and LA being west and New York being east do. I just care how far it is from 0, what that distance is. And if absolute value is a distance from 0, distances are always positive. Distances are never negative. Like, when's the last time you said, oh, well, I'm going to go drive to the store, and the store is negative 10 miles from my house? It doesn't happen. The store's positive 10 miles from my house. So absolute value is always positive, which you probably remembered, but I'm not sure if you realized it's because by definition, absolute value is the distance from 0. Distances are never negative. You can't walk a negative distance, okay? So therefore, absolute value makes everything positive, okay? Absolute value is the distance from 0. So I set up 2 absolute value equations here. This notation, they look kind of like bars on either side of the 2n minus 1 or the 3n plus 4. That indicates absolute value. And I set up these 2 absolute value equations because I want you to see them compared to this graph right here. So if I want to talk about the distance of 2n minus 1 being 7 units away from 0, then that means I could be 7 units to the left of 0 or 7 units to the right of 0. Well, what that means is that what's inside this absolute value symbol, this 2n minus 1, that could be negative 7 or it could be positive 7. And that's the first big change with absolute value equations. Whenever you see an absolute value equation, like absolute value of 2n minus 1 equals 7, it could be the dot on the left, there's always a dot on the left, or the dot on the right. It could be negative 7 or it could be positive 7. So what you do is you take whatever's inside the radical, 2n minus 1, and you say, hey, whatever's inside the absolute value bars, I take that, which is in this case 2n minus 1, and it could be negative 7 or it could be positive 7. And then I solve them each individually, okay? So I add 1 to both sides. 2n is negative 6, divided by 2n is negative 3. Real simple equations to solve. Add 1 to both sides. 2n is 8, divided by 2, n equals 4. So again, not difficult to solve at all. When we're done, we realize that with absolute value, we have 2 answers. And that makes sense because absolute value means the distance from 0, which means we could have 1 answer on the left, or we could have 1 answer on the right, or should I say we have both answers. So in this case, there are 2 answers. They are negative 3 and 4. And notice we put them in the squiggly, fancy bracket symbols. Okay, that's the set containing 3 and 4. That's what that means. Okay, so let's see you try the next one. 3n plus 4 equals 7. Go ahead, give it a shot, and then I'll show you the answer in, well, my time, only about 10 seconds. Your time, as long as it takes you to get the equation, the absolute value equation, solved. Okay, so maybe the 3n plus 4 equals negative 7, or maybe the 3n plus 4 equals positive 7. Solve them each individually. minus 4, I get negative 11, divided by 3, and I get negative 11 thirds, which is negative 3 and 2 thirds. Brief commercial interruption. Unless you see answers to a multiple choice quiz, test or quiz item, do not convert to a decimal. You can only get it more wrong. Leave it a fraction, okay? Next up. And by the way, if you'd have written negative 11 thirds, I would have accepted it. Next one, the 3n plus 4 can equal positive 7. So I subtract 4 from both sides. I get 3n is 3. Divide by 3n is 1. Notice that notation we spoke of just a minute ago. The two potential answers to correct answers are negative 3 and 2 thirds and 1. Okay, so let's have you try this guy. Let's have you try first the one on the left. Go ahead. All right, so since we're doing stop and start, I think we're ready to rock. And that means 2n minus 1 could equal negative 17, or it could equal positive 17. So there is a rhythm and a routine to this. You always take whatever's inside the absolute value symbols and you write down equals the negative of the other side or the positive of the other side. Adding 1 to both sides, 2n is negative 16. Dividing by 2, n is negative 8. On the other side, add 1 to both sides, 2n is 18. Dividing by 2, n is 9. So there are two potential answers, negative 8 and positive 9. If we go back and substitute them in, you'll see that they check. All right, what's 2 times negative 8? It's negative 16. Minus another 1 is negative 17. Now the absolute value of negative 17, we said absolute value always makes things positive because it means the distance from 0. So the absolute value of negative 17 is positive 17, which it's supposed to be. And then 2n minus 1 equals 17. 2 times 9 this time is 18. Minus 1 is 17. The absolute value of positive 17 is also positive 17. Sometimes students think absolute value changes the sign. It does not. It makes it positive. Remember always, absolute value is a distance, namely the distance from 0. So absolute value is always positive because distances are always positive. All right, let's see you try the next one. Absolute value of 3n minus 4 equals 7. Go ahead. Okay, let's check in and see how you did. 3n minus 4 is negative 7, or 3n minus 4 is positive 7. Adding 4 to both sides, 3n is negative 3. Dividing both sides by 3, and I get n is negative 1. On the other side, adding 4 to both sides, 3n is 11. Dividing by 3, I get 3 and 2 thirds. There's my answers in set notation. Negative 1 and 3 and 2 thirds. Okay? All right, let's try another absolute value equation. This one, what do you notice that's different here? Yeah, it doesn't equal like 17 or 9 or something like that. It equals n plus 3. But don't change a thing. Absolute value means distance from 0. Maybe that's the negative of n plus 3. Maybe that's the positive of n plus 3. So you give it a try. Let's do stop and start. Give it a try. You might stumble on the way here, but that's all right. You will learn from your mistakes. It's not an issue. Sometimes, students, they think sometimes that they got to be right all the time. No, absolutely not. The most important thing is that you're always in learn mode. And sometimes you have to make mistakes to learn. All right. If you're getting it all right without making any mistakes, then it's not challenging. And if you're never challenged, you're never improving as a person. You're never getting better. Okay. So give it a shot. Do what you think you should do. There's a good chance a number of you are going to make a mistake. And then we'll come back. We'll correct it, obviously. And then we'll go into the next one. And there, I trust that you will not make the same mistake. So a little stop and start. Problem on the left. Go ahead. Okay, so maybe the 5n minus 1 equals the negative of n plus 3. The big thing I think students might do wrong is I think they might not have put the n plus 3 in parentheses. Okay, it's the negative of whatever it says on the left-hand side. Just to go back, I want to go back to the previous slide. See, it's the negative of whatever it says on the right-hand side. It's negative 17. or it's positive 17. It's the negative of whatever it says the right-hand side. It's negative 7 or it's positive 7. So likewise here, it's the negative of whatever it says on the right side. Since there's two things on the right side, I want to make sure I put the whole right side in a parenthesis. Now I distribute, that makes it negative n minus 3. And now this is just an opposite side, opposite operation. This is pretty straightforward. Adding n to both sides, 6n minus 1 is negative 3. Adding 1 to both sides, 6n is negative 2. Dividing by 6, and I get n is negative 1/3. On the other side, it's just 5n minus 1 equals n plus 3, so it's kind of business as usual. I almost always start with the n's. For some reason on this one, I started with the ones. Oh well. I get adding 1 to both sides, I get 5n equals n. Oh, I want to go back on that. I get 5n equals n plus 4. Subtracting n from both sides, 4n is equal to 4. Dividing by 4, n is equal to 1. So my two correct choices here are negative 1 and 1/3. And they would check. They would absolutely check. Okay. If we go to this last one, if you made that mistake with the negative and the parentheses and forgot about the parentheses, which is something students are likely to do when they first see this, let's not make the mistake on this one. Go ahead. Okay, so maybe the 8n minus 4 equals the negative of 3n plus 11, or it could equal the positive of 3n plus 11. If it's the negative, I have to distribute that negative sign to everything in the package, or the parentheses. That's negative 3n minus 11. 8n minus 4 is negative 3n minus 11. Adding 4 to both sides. Again, I usually start with the n's, but this time I just felt like starting with the numbers. No big deal. 8n equals negative 3n minus 7. Add 3n to both sides. 11n equals negative 7. Divide by 11. N is negative 7/11. Over here, 8n, I'm going to add 4 to both sides. 8n equals 3n plus 15 minus the 3n. 5n equals 15. Dividing by 5, n is 3. My correct answers are negative 7/11, which was a store I used to frequent years ago. My dad loved their coffee. And 3 are the correct solutions there. Okay? So, do I have another one here? Yeah, I do have another one here for you to do. Good. Let's have you do these two more. Go ahead. Stop and start. Only do the first one, okay? First one, stop and start. Then we'll do the second. All right, so maybe it's the negative of n plus 3, or maybe it's the positive of n plus 3. So 4n minus 2 is the negative of n minus 3. Adding n to both sides, 5n minus 2 is negative 3. Adding 2 to both sides, 5n is negative 1. Dividing by 5, negative 1/5. Okay, good. On the other side, it just equals n plus 3 because we don't need to negate it, right? We could be the negative side of 0, or we could be the positive side of 0, because absolute value means distance from 0. 4n minus 2 is n plus 3. Adding 2 to both sides, 4n equals n plus 5. Again, I always start with n's, but I must have had a template here where I started with the numbers. Minusing the n from both sides, 4n is 5. Dividing by 4, that's 1 1/4. So there are my two correct answers shown for you. So once again, I think I think I might be going too fast. I think I might sound a little... it might sound disinterested, but I don't mean it to. What I mean it to sound is routine. That when I solve an absolute value equation, well, maybe it's the negative, maybe it's the positive. If it's the negative and they give me variables like this binomial expression here, n plus 3, I just say it's the negative of that thing on the right-hand side. That's all. So if it's the negative of that thing on the right-hand side, I just write it out as negative and I put the whole thing in a parenthesis. And then just algebra says I got to distribute that negative sign, and then I go about solving it. And I know you're great at solving once we get it done. The whole thing is, do you remember to say, okay, well, it's absolute value, so there's two ways we could go here. We could go that it's the negative or that it's the positive, because either way, if it's the negative, when I take the absolute value, because absolute value is a distance, I turn that negative into a positive. And if it's a positive, well, I'm going to keep it positive because absolute value is a distance and a distance is positive. Okay? So I hope that I don't sound disinterested. I hope that I don't sound a little less passionate, but it's pretty routine. And I think that once you see the routine of it, you're just like, oh, I got this. All right, we do a little of this, we do a little of that, we get the answer. That's all. All right, so let's try. I'm not Italian. Sometimes I wish I was Italian because they make the best food. Okay, let's have you try this last one here, the last absolute value equation, I believe, of this particular video. Yes. Oh no, do we have another one? No, we have another one after this. Okay. No, the one after this is the same one. No, this is the last equation one. Go ahead. All right, let's see what we get out of this, all right? So remember, we're casual about it. We're not uptight. This 8n minus 4, well, maybe it's the negative of whatever's on the right, which in this case is a 5n plus 11. Or maybe it is the positive of it, which is just leave the 5n plus 11 alone. Distribute that negative sign. I get negative 5n minus 11. We just started with the same template, so I keep doing numbers over and over again. But add 4 to both sides. I have negative 7 there. And then I have to add 5n to both sides. I get 13n is negative 7. Dividing by 13, and I get negative 7/13. Is that a pretty answer? I got news for you. With absolute value, it's pretty rare that both of the answers come out to be nice, beautiful whole numbers. Most of the time, one or both turns out to be in a less than beautiful number. All right, on the other side, 8n, we add 4 to both sides. So 8n is 5n plus 15, right? Because 11 and 4 make 15. Subtract 5n from both sides. I get 3n is 15. Dividing by 3, n is 5. So I got one nice one out of this. So negative 7/13 and 5 are the correct answers. So that was a pretty long video. I'm looking at my counter here. That's about 18-minute video. It's like 2 videos in one. And now we're about to start absolute value inequalities. But that is the next video.